Hello everyone, let's solve question number 27 of GATE 2025 CS1 paper. A partial data path of a processor is given in the figure where RA, RB and RZ are the 32-bit registers. Which one of the following options are correct related to the arithmetic operation using the data path as shown? So this is a figure given to you. So you can see there is a multiplexer A, multiplexer B, and there is a select RA slash immediate, select RB slash immediate, where RB is a 32-bit register and immediate is an immediate value. So two kinds of inputs are coming in the multiplexer. One of them is a register of 32-bit, another them is a immediate value of 32-bit. There is a arithmetic logic unit, and the kind of operation that will happen is being controlled by ALU control lines. And the RZ register is the destination register which holds the output of after the arithmetic operation is performed. So let's understand that. Let's understand the prerequisites here, and then we will try to solve this particular question. So let's first understand what are the data paths. We are given a partial data path of a processor that performs arithmetic operations using ALU. You are given a 32-bit RA register, which is a general purpose register. You are given a 32-bit RB register, which is another general purpose register. You are given RZ, which is the destination register that stores the result of the ALU. ALU is arithmetic logic unit. Immediate values are nothing but the constant, which are numbers hard coded in the instruction, usually in the operations like add, R1, R2, 10. So it is like this. Add, after that I can write R1, then I write R2, and then I write 10. So this is the hard coded value and this is the register value. Okay. So this is one of the operations. Okay. What is a multiplexer? There are 2:1 multiplexer. That means each one of them choosing between a register value or a immediate value. Multiplexer A selects between register A of 32-bit and a 32-bit immediate. Multiplexer B selects between register B and a 32-bit immediate. Okay. Each multiplexer is controlled by a select line. So that select line controller decides which one to choose. So it can either choose select RA comma immediate, or it can do select RB comma immediate. What is ALU? ALU takes 32-bit inputs from the outputs of multiplexers, and once the ALU take inputs, they are controlled by ALU control line, which determine the particular operation. Either you want to add, either you want to subtract, multiply, etc. Output will be a 32-bit result that will be stored in the Z register. Okay. So let's actually analyze the options. So data path can implement arithmetic operation involving two registers. If both select RA slash immediate and select RB slash immediate are set to choose between registers, then they can do combinations. So what combinations are there? We can check that. So RA and immediate value, let's call it IB. And there is RB and another immediate value. Now tell me the possible combinations present. RARB, RBIV, immediate value, RB, immediate value, immediate value. So four combinations are there. Total four combinations are possible, which are, let's call it set wise. Yeah, this is set A, set B. Then from A to B, what are the options? RA, IV, one of them. RARB, second. IVRB, third. IV. Total four combinations are there. So if multiplexer A and multiplexer B outputs RA and RB, which are the registers, obviously it is possible. It is possible. These are the two values that will be go to the arithmetic logic unit. Arithmetic logic unit will perform the operation based on the ALU control lines, and the result will be stored in the destination register, which is RZ. So for example, if I write add, RZ, comma RA, comma RB, then execution will be like this. Multiplexer A, multiplexer of A, and multiplexer of B will be here. And ALU will be having RA plus RB, and RZ will be holding the result of that, whatever result we get from RA plus RB. Okay. So this is a classic register to register arithmetic, and option A is correct. The data part can implement arithmetic operation involving one register and one immediate value. As said, there are possible combinations which we can follow. So let's say it is correct because either the register can choose zero. Zero means, so what are the options it can give? Zero means it choose register. If the multiplexer outputs zero, then that means it choose register. And if it outputs one, then that means it choose the immediate value. So if both the multiplexers somehow give out immediate value as if they want to select, then both of them will be outputting one. So this is what the demonstration will look like. Add multiplexer, sorry, add RZ. We will store answer in the RZ, and RA we will add, and we will add 10. So this is how we write it. So multiplexer A will hold RA, and multiplexer B will take an immediate value 10, and ALU will do RA plus 10. Result will be stored in RZ. And this is a register immediate value arithmetic, and option B is correct. Option C, the data path can implement arithmetic operation involving two immediate values. Again, uh, it is completely possible if both the multiplexers output one. That means they are actually selecting the immediate values. So it will look something like this: add RZ hash 5 hash 10. That means this will be in the multiplexer A, this will be from the multiplexer B. If one is being given the output, then it means these values are selected. RZ will be holding the result of that. ALU will perform the operation, and RZ will be holding the answer to that. So option C is also correct. So A, B, C, all three are correct. Let's understand option D. So data path can only implement arithmetic operation involving one register and one immediate value. That's false. It You can see all the three options which are correct. Since A, B, C are correct, the option D itself contradict the previous options because it can implement arithmetic operation involving one register, one immediate, one register, one register, immediate, immediate, immediate register. All four combinations are possible. So option D is correct because it is not the only implementation as it asks. Okay. The only keyword, hence make sure that the given option is incorrect. Also, if you want to understand a bit more, let's understand what the control signals arise. So an instruction, typical RISC style instruction in encoding like this. So this is how an instruction bit. So let's first understand some more things. We have already done the question, but let's understand second way to solve the question because there are multiple ways to do that. So another theoretical point which when we can start from is instruction fetch and decode, how the control signals arise. Okay, so instruction bits are basically a typical RISC style instruction. It is encoded like this for a three operand operand format. So it first has the opcode, then it has RS1, then it has RS2, then it has RD, and then it has the function. RS1 and RS2 are the select source registers, and RA and RB. RD is the destination register, and immediate field is live in other formats, which is I type or U type. But the control unit knows the opcode whether it should read an immediate or to register or a mix. So basically, the control unit knows from the opcode. The opcode ensures what it is reading. क्या read करना है उसे? What are the control unit outputs? So the opcode plus function fields from the opcode plus function field. Addition of both of them. Addition of these two, opcode and function field, both of them addition. If select A is 0, that means RA is choose one to choose immediate. Select B 0 to choose RB, 1 to choose immediate. 0 means register, 1 means immediate. I already said. ALOUP is equal to, so there is a term called ALOUP, ALU operation. ALU, arithmetic logic unit operation. It is basically either I will do add, subtract, and or whatever I want to do. This is what it is. Okay, so a register file is really just a small SRAM. Let's understand what is a register file. It is a simply small SRAM with multiple read ports. Okay. So a register file basically it's small SRAM. Uh, it has multiple read ports and port 1 is RA and port 2 is RB. It is a 32-bit out. On each clock, register uses RS1 and RS2 fields to output a two 32-bit values in parallel. Immediate generator, an I-type or the other immediate bearing instruction, the control unit slices out the immediate bits from the instruction. The sign extends or zero extends them through the 32 bits. 32-bit constant is now available on an immediate value line to each multiplexer, or we call it MUX. So MUX here is a 2 is to 1, taking input 0, which is register, input 1, which is the immediate value. 2 is to 1 is often built as, like, let me write that. So a 2 is to 1 multiplexer is often built in a way that out is equal to minus select, and in 0, we select, and in 1. Let's understand what these terminologies are. So, if select is equal to 0 and out is equal to in 0, select is equal to 1, then output is equal to in 1. Propagation delays. Typically, couple of gate delays in high-speed pipeline, your budget for the ALU stage timing. ALU combination arithmetic logic. Okay. So, let's understand that. So, A of 32 bits is equal to output of MUX A, output of multiplexer A, and IB of 32 bits, it's output of multiplexer B. Now, inside we have got a carry look ahead adder. Now, what is a carry look ahead adder? It is for additions of, if we want to invert one input and plus carry in, and or trees, shifters, etc. multiplexed for all arithmetic logic operation unit operations. Result out goes to the write back. Now then add is selected, so result is equal to IA plus IB, and then write back happens into RZ. So if reg write is equal to 1 on the next clock edge, then ALU result is being stored inside the RZ, which is the destination register. Okay. Thus, whichever values you ran in through multiplexer A or B, and the ALU ends up in the destination register. Okay. So putting it all together, multiplexer and selections are there. So there are several operation type: register to register, register to immediate, immediate register, immediate, immediate. Even immediate register or immediate ALU operation are perfectly valid at a data path level. They just don't always correspond to a name assembly mnemonic, but a hardware. But actually, the hardware's some of them. Mnemonic, it is not supported, but the hardware actually supports. So that's what it matters. So that is why option A, B, C are true, and option D is false, because the only keyword in option D is actually restrictive. Okay. If you don't get the example, imagine everything like a sticky note. So let's say you want to add 7 and 12, so you want to return some 19. You read the first note 7, then you read the second note 12, and add both of them and write the result. This is what you have to do. CPU data path look exactly like that. It reads, add, and then write. Read and write operation they do basically. Okay. So the sticky notes inside the CPU are actually the register. Register are the tiny super fast sticky notes inside the chip. Each one of them hold a 32-bit number. We have labeled up two of them as RN and RB, which are our source nodes. RZ is the destination node. So I'm trying to give a real life terminology of whatever we have covered till now. Immediate values are hard-coded constants. Instead of reading a number, I can directly put a value. That is what it is. It remains in the instruction itself. We call it immediate. It is writing +5 on the command if I'm choosing 5 on the CPU, and directly ask it to grab it. So how does a CPU choose between register and an immediate? We have a railroad switch or a multiplexer. We have a switch with us, which is the multiplexer. It sits and it routes either a register track or an immediate track. It is like a tracker, switcher. What does switcher do? It tracks like, okay, कहाँ जाना है, क्या चीज choose करनी है. ठीक है, so multiplexers does that. If level is down to 0, then it connects the register track, or if it is up to 1, then it connects the immediate track. Okay, so there is an adding machine inside it. You can understand like that, that there in arithmetic logic unit there is a wiring, there is a wired up of addition subtraction. We call it control lines. So it expects to input the output of both the multiplexer and split out into one result and write that into the destination register. Okay, so I tried keeping everything like very simple. I hope that is clear. You can like still draw a bit of diagram to understand it. So we are given a register and we are given an immediate value. It goes through the multiplexer here, and then let's call it RB, and this is an immediate value. Both of them goes through the multiplexer. Let's say M of B, and after that select RA comma immediate, select RB comma immediate. It is passed through the ALU. ANU through the control lines defines the operation, and then the result is being popped out. Result. Multiplexer can pick any one of them depending upon the kind of where it want to. Okay. So that single 32-bit output file is written in the RZ register. Okay. So that's it. That's it for this particular question. Take care. Bye bye. See you guys in the next video.